Okay. Okay.
Okay.
Good morning, Ravi sir.
Sir, good morning. Course చేయండి సార్ నన్ను. పోస్ట్ చేశారా?
Yes.
ఓ హోస్ట్ చేయపోయారా?
Okay.
నేను స్క్రీన్ షేర్ చేస్తా, చూడండి ఒకసారి వచ్చింది.
వచ్చిండ్రా.
షేర్ అయింది కదా?
షేర్ అయింది. అది ఫుల్ మోడ్ లో పెట్టు స్క్రీన్.
ఫుల్ మోడ్ లోనే పెట్టాలి కదా?
ఓకే ఓకే ఓకే. నా
అదే
సెట్టింగ్
ఇట్లా టైటిల్ ఉండిద్ది, ఆయన పేరు ఉండిద్ది. ఇక ఆయన గురించి వెల్కమ్ నోటు, ఆయన అది సమ్మరీ ఉంటది, గెస్ట్ ప్రొఫైల్ సమ్మరీ. ఇది చూసే చదువుతానన్నా నేను.
ఓకే ఓకే.
అంతే. ఏం స్క్రీన్ పోయింది?
నేను వర్స్ట్ లెక్కలు తీసి మళ్ళీ నేను వర్స్ట్ అయినా.
అవునా?
నేను కోస్ట్ చేసిన.
ఓకే, ఇప్పుడు చేయొచ్చు కదా.
షేర్ చేయి ఒకసారి.
వచ్చింది కదా.
ఓకే ఓకే
రైట్.
రైట్, ఎంజాయ్, నో ప్రాబ్లం.
సార్కి మెసేజ్ పెడతా. అరే ఎవరు లేరు కదా మనోళ్ళు.
Okay. Example lecture using CVR email ID.
మెసేజ్ చేశాను సార్ ఆయనకు కూడా. ఆయన కూడా లాగిన్ అవుతారు. ఆయన లాగిన్ అయితే ఆయన కూడా కోవిడ్ చేసేయండి అలా.
అయితే పిల్లలు లాగిన్ అవుతారు కానీ ముగ్గురు లాగిన్ 327, are you there? 19B 327. 317.
Yes, sir. 327.
Please inform your classmates to join for lecture. I
Okay,
already
sir.
kept the message. Please inform once again.
Okay, sir.
Okay. 316. Please inform your classmates to join for lecture. Okay.
I'll do that, sir. I'll do.
Okay. And tell them to join with CVR email ID.
Okay, sir.
Okay. Okay.
Good morning, sir.
Good morning, Amma. Sir, good morning, sir. Raghava, sir, good morning, sir.
Yeah, good morning.
Sir. Sir, yes, sir, please check sir's voice. Is it clear or audible?
Yeah, good morning. Hello. Is it audible?
Audible only, sir. Audible, not an issue. Good morning, sir.
Yeah, good morning. Sir. Good morning.
Sir, he is P. Srinivas Reddy, sir, senior assistant professor in mechanical department, sir.
Yeah, hello, sir. Hello.
Good morning, sir.
Since last 12 years, he is working, sir. Previously, he is with IIC-CVRCoE, sir.
Okay, sir. Okay.
From last 10 years with CVR, sir.
Okay, fine. Hello, sir. Hello.
Oh, sir. Hi.
Sir, we'll wait 5 minutes, sir. Then starts.
Yeah, fine. Okay.
పోయిండు చూసుకొని పోయిండు చెప్పిన
right to the field of discussing it.
Good morning, Kishore sir.
Good morning, sir. Yes, sir.
Good morning, sir.
Ravindra sir, join in.
Sir, I heard sir.
Join ayyar, sir.
జూనియర్లు కూడా ఉన్నారు వీళ్ళు.
Okay, sir. Dr. Ravindra, sir. It's already 35, sir. We'll start the session, sir.
Yeah, please. Yeah.
So, good morning to all, honorable guests and department HOD sir, dear colleagues, dear students. A very good morning and warm welcome to all. So I'm inviting all on this online expert lecture on introduction to metal matrix nano composites. I hope this lecture will be fruitful and helpful to us. Before starting the lecture, I would like to honor our guest, Dr. G. Raghavendra sir. So, Assistant Professor in Department of Mechanical Engineering and IIT Warangal. So, sir, this is our summary of the sir. So, sir did his PhD in Mechanical Engineering from NIT Roorkela, MTech from NIT Roorkela, and BTech from Bapatla Engineering College. So, sir is an active reviewer in many reputed journals. Some of them are, we have given World Academy of Sciences, Engineering and Technology, Caspian Journal of Applied Sciences Research, Journal of Elsewhere, Journal of Composites, Proceedings of the Institute of Mechanical Engineering. So, sir have several professional bodies membership also like IIMG, SME, TIE, IIC-CVRCoE. Sir guiding 12 PhD students, 2 of them are completed, 10 are ongoing. Sir completed one DST project also on fabrication and characterization of porous nanocarbon from activated bio waste for tribological and structural application funded by sir with 37.1 lakh. And sir got awards like gold medal certificate and Ganesh Mishra Memorial Award for the best research finding in natural fibers by Institute of Engineers, Orissa government. Honored with 4 times Best Paper Award for best presentation by different institutes like IIC and NIT Roorkela. Bronze medal and Young Scientist Award for best research finding in biocomposites from OIRA 2016. Young Engineer of the Year Award for best research finding from Telangana State and Institute of Engineers in 2018. Sir has excellent publication career, 47 SCI journal papers, 45 international conference papers, 10 Scopus journals, 12 book chapters, 12 non-SCI journals, 9 national conference papers. On this note, once again, thank you all for being here today. I'm handing the session to the my associate professor, Dr. K. Kishore Kumar sir, to welcome the sir. Sir Kishore sir.
Thank you. Sir, good morning, sir. Raghavendra, sir. This
Yeah,
is
good
Kishore.
morning, sir. How are you?
Fine, sir. Fine. Thank you. After a long time.
Yes.
Sir, on behalf of our HOD and our department, I welcome you to this session, sir. Thank you very much for agreeing, and please motivate us by your session.
Yeah, sure.
Thank you.
Yeah.
Yes, sir. Sir, I am stopping the screen, sir. Yes, sir. Sir, please continue.
Yeah, I'm sharing the screen.
Sir.
Is the screen visible?
No, sir.
Yes, sir.
Yes, sir. Yes, sir.
Now, yes, sir. Okay.
Yeah. So good morning, everyone. So thank you for the introduction. I'm Dr. Raghavendra, working as an assistant professor in mechanical department, NIT Warangal. So today's topic is about introduction to nanomaterials, nanometal matrix composites. So coming to the topic, my presentation outlines, my topic outlines are introduction to materials. First of all, we'll talk about what are the different kinds of materials which are available. After then, composite materials and nanomaterials and MMCs, metal matrix composites, and the fabrications related to metal matrix composites. So coming to materials, basically, the classification of a materials starts with engineering materials. People learn or people know about more about engineering materials. So, but the basic classification start with man-made materials and natural materials. The materials which are available in the nature are called natural materials. So, like stones, bones, skins, wood material, mud and clay materials. These are which are available in the nature. So these materials are called natural materials. The man-made materials, which are prepared by a man, are called polymers, ceramics, ceramics and metals. So from the metals, again, we have alloys and refined ores like other materials. From polymers, we have plastics, thermosets, and thermoplastics. And there are some classification of the polymers and elastomers. And ceramics, there are again sub-classifications. Metals also, there are sub-classifications based upon the alloys and combinations of those. So the basic classification of a material starts with a natural and a man-made materials. So coming to engineering materials, which already many people or everyone learned about these engineering materials, it consists of like metals. Again, all these are called man-made materials, like metals like ferrous and non-ferrous, amorphous. There are sub-classifications. I'm not going deep into the particular materials as our topic is about metal matrix. So quickly I'll complete this, like plastics, thermoplastics, thermosets, elastomers, ceramics and others, and particularly composites. So the metals and plastics combinations and metals and ceramic combinations are the plastics and ceramics are the metals and ceramic combinations gives you the composites. The reinforcements as a plastics, a metal matrix and ceramics, laminates and others. So these entire, the combination of the metals and plastics are metals and ceramics and plastics gives you a composite. So these are about the engineering materials. So there is an evolution of materials from ages. Like if you see in the chart, the 10,000 BC, the few materials which are started there, like for example, gold. From 10,000 BC, we have a gold. 5,000 BC, we have a copper, bronze, iron, the cast iron and steels. You can see it, the metals which are flowing from 10,000 BC to present trend. So now we have a metal matrix composites and advanced materials, functional materials, smart materials. So all are comes under the metals. When it comes to polymers also from the ages we have 10,000 BC, we have a wood, skins, fibers, and different kinds of glues. And now we have a polymers like thermosets and thermoplastics. And from ancient times, these composites are not a new material. From ancient times we have, but especially not metal matrix composites. Ancient times we have like the construction applications. People developed mud straw bricks and papers. So all those comes under composites. And the evolution of even from 10,000 BC, we have a composites. Those composites nowadays we are more popularly called as like metal matrix, ceramic matrix, polymer matrix. So all those composites we have. And from ancient time, we have different kinds of ceramics, different ceramics for high temperature applications. This is the evolution of a materials from 10,000 BC to the present trend. Particularly, why we need these composite materials? What are the need of advancements of this, and why we particularly need these composite materials? Already we have a metals, already we have a polymers, already we have ceramics. Why we need to develop these composites by combining a metals and ceramics, or a metals and polymers, or a polymers and ceramics? These are the reasons we required a strength. Already strengths are available. To enhance strengths of the materials, we need to go for a composites. And we need stiffness, toughness, corrosion resistance, wear resistance, and reduced weights to reduce the weight of the materials. How to reduce it? For a material directly, we can't reduce the weight of the material. We can't reduce straight away the density of that material. By combining, we can reduce the weights of the materials and increase the fatigue life, thermal and electrical conductivities. So these are the properties which are needed to develop a new kind of composite materials. So coming to the definition of a composites, composites are the combination of two or more materials in a macroscopic scale. And those composites, when we combine two or more materials, they act as a single material. after combination, but they don't lose their original properties. Here comes like, what is the difference between an alloy and a composite? Both in a alloy also we are combining two or more metals. Why we are calling that an alloy? Why the composite? Here, the composite, we can combine two or more materials or metals, but they don't lose their original properties. What are the base materials which we mix? Those base materials remains like a same material and they don't lose their original properties. When it comes to an alloy, the alloy, when we combine two or more metals, the base materials lost their original properties and form a new material. The new material having a new properties. And we can't easily separate the two base materials from the alloy. So that's the basic difference between an alloy and a composite. When it comes to composite, we have a reinforcements and a matrix. There are two phases in a composite. We'll have a reinforcement phase and a matrix phase. It gives you a composite. Examples of that particularly are mud straw bricks, concrete, and glass fibers. There are many applications. A few are quoted here. Sorry. So coming to the phases, what is a matrix and what is a reinforcement? Coming to the matrix phase, it is made up of from like metals, polymers, and ceramics. We can use any of these, like we can use metals, or we can use a polymers, or we can use a ceramics as a matrix materials. This is a continuous phase. This particularly binds the fibers. It transfers the load. It supports mechanically the reinforcements, the load transformation to the fibers, means to the reinforcements. The purpose of the matrix is, whether it may be a metal or a polymer or a ceramic, it always supports the reinforcements and it always transfers the load from one fiber to another fiber, one reinforcement to another reinforcement, like a mechanical support. So the entire strengths or load transfers from one fiber to another fiber through this matrix. So the matrix is a fully supported, it is covered the entire reinforcements. So these are the few properties of the matrix materials. When it comes to reinforcements, the reinforcements is a stronger material. The load which you apply on the particular composite, the entire load will be carried by the reinforcements. And this will be a continuous phase or a particle phase. The entire load which is applied to the particular composite will be carried by this reinforcements. So this is a main important material which carry the load, and the strength of the composites will be decided by these particular reinforcements. So these are the few properties of a matrix and a reinforcements. We'll see like a classification of a matrix. First thing is a metal matrix. The main topic of today is about the metal matrix. So what kind of fibers we can add? We can add a boron, carbon, graphite, aluminum, silicon carbide, and the other matrix. Particularly, these are the fibers which we can add into the metals. We can use a different kind of metals like aluminum, magnesium, some examples, titanium, copper. So these kind of metals, in that particular metals, we can add a different kinds of reinforcements. And particularly these fibers improves the temperature resistance, temperature creep, and thermal expansions, coefficient of thermal expansions, all those tribological properties, mechanical properties. So to enhance the properties of these metals, we add different kinds of fibers into particularly the matrix. Coming to the polymers, we have thermosets and thermoplastics. Again, I'm not go deep into the particular thermoplastics and thermosets. We have talking about more about metals. So the polymers are the materials which are more lightweighter when compared to the metals, which are more advantageous when compared to metals, not in terms of strengths, in terms of densities, in terms of their lightweight, in terms of their flexibility in manufacturing. So these are certain advantages with the polymers. There are few disadvantages when related to the metals. They won't give high strengths as like a metals. The polymers gives you less strengths, and these are the weaker materials when compared to other ceramics and metals. Coming to the other phase, the ceramic matrix, CMCs, it having a fibers like silicon carbide, alumina, and silicon nitride, and other fibers are there. In a matrix, again, we can use the same kind of alumina, silicon carbide, and so called as ceramic composites. Ceramics as a fillers and ceramics as a reinforcements. So it improves toughness and some other properties related to it. This is a general classification of a matrix material. If Quickly, we'll see like reinforcements, what kind of different kinds of reinforcements that we can add into a composite. So we can add a particulates composites. Particles can be added. So whether it may be a matrix, whether it may be a metal or a polymer or a ceramic, we can add a particles to it to enhance the properties. Sometimes it may be used to enhance the property. Sometimes it may be used to decrease the properties. It depends upon the applications. So the particles composites. And coming to the fibers and whiskers, we'll have a unidirectional discontinuous fibers. So then the entire composite in a unidirection, we can add the fibers that is called unidirectional discontinuous fibers and a random oriented. We are not particularly focusing on any direction of the fibers. So we randomly add that particular particles or fibers or flakes directly in a random directions. So this is called random oriented discontinuous fiber composites, and preferably in a unidirectional fibers. You can see it like in a one direction, we are adding all the fibers from one to another the plate. Continuously, there will be a fibers, so called as unidirectional continuous fiber composites. And sometimes if you apply a load in this direction, the fibers are there, then to use your high strength. If you apply a load in this direction, there are no fibers, automatically the strength will be very weaker in this direction. So that's why people developed a cross splice. In both directions, we have a fibers. In whatever the direction, whether it may be this direction or this direction, we'll have a strength. And this is about the multi-direction. So in all the directions, we have a fibers. In this direction, in all the directions, we have a fibers. So in whichever direction we can apply the load, then we'll have the fibers. It gives you a high strength. These are more advancements: unidirectional, bidirectional, and multi-directional continuous fiber composites. So this is about reinforcements. So coming to the phase called a filler composites. So in a composites, when we add a fillers, particularly to a composite, we call that as a filler composites. In this particularly, we'll have micro fillers as well as a nano filler. So today we'll talk about nano filler composites. Before that, we'll see some examples like metal powders. Metal powders can be used as a fillers, aluminum, carbon, magnesium, titanium dioxide, zirconium dioxide. So these are the few metallic powders, the powders which are available in terms of fillers. These can be added to a metal matrix composites based upon their melting points. And then we can develop new kind of a composites by these fillers. So particularly as the topic is about a nano composites, I'm not talking about the micro level. Micro composites means the particle size, if it is in a micro level, then we call it as a micro composites. If the particles are in a nano level, then we call it as a nano composites. When it comes to the nano composites, mathematically, if you name it, nano means 10 to the power of -9. Already we know composites like a combination of a matrix and a reinforcement. Then what is that like nano composites? In the name itself, 10 to the power of -9 composites means the material which we can't see with our eyes, we can't see with eyes. So what is that particular composite? In the definition comes to that. If you see, nano composites means any one phase will be in nano level, any one dimension, whether the reinforcements are particles which we are adding into the composite. These particular reinforcements in that, if any one dimension, not all the entire particle, any one dimension is a nano level, then we call it as a nano composites. So there is no like z to the power of -9 composite. It is a material in the composite, any one phase will be in a one dimension will be in a nano level, then we call it as a nano composites. So first we'll see like what is a nano. There is a small comparison. This is a long back comparison, which there is a largest star. In that particular star, we compared the sizes. So as a time constraint, I'm not going deep into all the times. Like you can see in the screen, this is when compared, it is almost 1,900 times to the sun's diameter, 342 times to the earth diameter when compared to sun, and taken a small child of 1 meter height. And this is the distance, like how much times it is bigger. And when it comes to the macro level, we have a penny coin, which is a 2 centimeters, and a raindrop 1 mm, and hair diameter, the least size which we can see with our eyes. It's not a hair length, it's a hair diameter. The diameter of the hair, which is almost 100 microns, that is the least size which we can see with our eyes. So after this particular 100 microns, then we need some extra components to see the particular sizes of the materials. Like for example, red blood cells in a bulk we are seeing, as a single we can't see it because of 5 microns we can't see it. So this is, we can see only with the microscopes, with the help of a microscope, with magnifying it, and we can see these particular sizes. And now we enter into a nano zone where we can't see with our direct eyes. We need certain components to see these particular terms. Like for example, flu nanometers, bacterial phase, this is 60 to 70 nanometers. And the gold particles are a nano clay, which is almost 13 to 50 nanometers. The DNA is the 2 nanometers. The least size in the entire world is a DNA, which is a 2 nanometers. That is compared with the Earth's diameter. This is like 12,756 into 10 to the power of 12 times bigger. So to understand a size of a material, we need to compare with the larger size materials such that we can understand what is the size, what is the smallest size of it. Because when we are magnifying it, when we are seeing the particle, we don't understand what is the size of it. When we are cutting into a lower levels, when we are going into the nano levels, then how the particle size is affecting. So, okay, fine. Now we have seen it. What is the least particle sizes? Already we know that in the recent past about the pandemic, all those stuff, the particle size, the bacterial and flu virus phase is almost 100 nanometers. That 100 nanometers, you can imagine like what that particular size of the materials, what they are doing it. So we'll see like a few terms like zero dimensional, dimensions, one dimensional, like all the dimensions, all the 3 length, breadth, thickness. If it is in a nano level, then we call as a 0 dimensional nanomaterials, the solid nanoparticles. One dimensional, only one dimension is not in the nano phase, nanorods. The length is not in the nano phase. The thickness and the width is in a nano phase, that is nanorods. And 2 dimensional, 2 dimensions are not in a nano phase. The length and the width, the thickness is in the nano phase, that is films and sheets. That is a 2 dimensional. 3 dimensional, no material are in a nano phase. I'm not going again deep into this particular nanotechnology. If you are interested, you can go through with the nanotechnology process, what are the different kinds of nanomaterials, how they are differentiated, and what is the classification of that, and based upon the particle size, dimensionality, and morphology, and then state and chemical compositions of the particular nanomaterials, how these nanomaterials are modified, and then how these nanomaterials are developed. So as we are talking about metal matrix composites, so I'm skipping it, like based upon the morphology, we'll have a classification. Based upon the state of the materials, we have a classification. And based upon the chemical compositions, combination of different materials, we'll have a different kinds of nanomaterials. Now we'll talk about like, what is the advantages? Why we need to study this particular nanomaterials and nanocomposites and nanometal matrix composites. These are nanomaterials. So if you see the advantage, to understand the advantage, simply the first advantage is, let us take one small cube. I'm taking one small cube of this, which is a side of a 5 centimeters, and the height and the width is the same, the 5 centimeters. Particular rectangle, rectangle is the area of this particular square is 5 into 5. It's a cube like having a 6 faces. So 5 into 5 into 6, that is total is a 150. The total surface area of this particular cube is a 150.